Welcome to Easy Limo Learning Simplified. My name is Eric. I'll be taking you through this topic, angles and plane figures. And for this particular subtopic, we are going to cover something on quadrilaterals, part A. And basically, what we want to look at, first of all, we want to see what quadrilaterals are and some of the angle properties involving quadrilaterals. And then we want to see how to solve problems involving angle properties on quadrilaterals. So we have a few questions on that to help us with illustrations on how we can solve problems which involves angle properties on quadrilaterals. And then of course at the end of the lesson we will be having some assignment just to help you practice and to help you gauge on your understanding of the concept as we are going to discuss during this lesson. So when you talk about a quadrilateral, we simply mean a four-sided plane figure, so there is E missing there, a four-sided plane figure. So previously we talked about triangles and we realized that a triangle was a three-sided plane figure. Now we have quadrilateral. Every time you have a four-sided figure, like a rectangle, square, and so on and so forth, those are the ones we are calling. Generally, all of them put together, we call them quadrilateral. Uh, we have one of the main properties involving quadrilaterals is that just like we saw in the previous case, we had sum of interior angles in a triangle summing up to 180 degrees. We also have sum of interior angles of quadrilaterals summing up to 360 degrees. So in the previous slide, we also looked at classifications of triangles. Similarly, we also have classifications of quadrilaterals, or rather, they are classified into different categories. We have things like rectangles, trapezia, parallelograms, and so on and so forth. So what qualifies, what qualifies one particular quadrilateral to be called differently or to be called a particular name? It depends on certain characteristics that it has, majorly based on the sides and interior angles. So we say that quadrilaterals are classified in terms of, one, you can use the sides, two, you can use the interior angles. We have the first one here called a parallelogram. So a parallelogram, what we call a parallelogram is when we have first characteristics. You have to look at certain characteristics that a particular quadrilateral has based on the sides or interior angles. For example, one of the main characteristics of a quadrilateral of a parallelogram as one of the quadrilaterals is that it has two pairs of parallel sides. Parallel sides. You can see this one side, this side is parallel to this side. So that is a pair, one pair. And then we have the other pair is this. You see. So this side is parallel to that. We have another pair this. So two pairs of parallel sides. It's a four-sided figure, and then we have two pairs of parallel sides. And then of course opposite sides are always equal. So this side must be equal to that. So you must have that. This equal to this and this equals to this. That's when you can conclude that that is a parallelogram. And of course, opposite interior angles are equal. So we mean this one here equals to this. And we also mean that this one here is equal to this. See, opposite interior angles being equals. And the diagonals bisect, the diagonals are bisectors of each other. So it means then this equals to this one here equals to this one here. See, so we say the diagonals, if you join this vertex to the opposite vertex, that's a diagonal. Again, this vertex to the other vertex, you join them, that is another diagonal. So these diagonals are bisectors of each other. It means the diagonal, for example, if this is AB, ABC, then D. The diagonal AB, AC, the diagonal AC bisects, that diagonal bisects the diagonal BD. It divides BD. The diagonal AC divides BD into two equal parts. That's why we have used those marks to show that. The same applies to BD bisects AC into two equal parts, as you can see. And finally, we have any pair of consecutive interior angles are supplementary, meaning they add up to 180 degrees. So if you take, maybe let me use now a different color so that you see it more clearly. If you take this one here and you add to this angle here, it should be 180 degrees. You see? Or you take this and you add it to this, it will give you 180 degrees. So any pair of consecutive interior angles are supplementary. They add up to 180 degrees. The second type of quadrilateral is called a rectangle. So rectangles also, we have these characteristics: opposite sides are equal and parallel. Yeah. So this side here, parallel to this. The same applies to this. So it also has two pairs of parallel sides. The difference now between a rectangle and a parallelogram is now a rectangle. Each of the interior angles, all the interior angles are right angles. They are 90 degrees each. And then another thing that makes triangle different from the parallelogram that we have seen in the previous example is that now the diagonals are equal in length. That wasn't the case with the parallelogram. So if you have this A, this B, this C, and then this is D, the diagonal BD is equals to diagonal AC. That makes it different. Of course, the diagonals are still bisectors of each other. So you'll realize that these quadrilaterals, there are certain characteristics they share, but then there are variations. They differ based on certain characteristics. Like in the previous example, when you talk about quadrilaterals, in the parallelogram, the diagonals were not equal. The diagonals were different in length. But now here, the diagonals are equal in length, you can see. Still bisectors of each other, but not equal in length. You can see that. Yeah, so there's characteristics the quadrilaterals they share. You'll realize maybe two or three they share certain characteristics, but then there are those that are different, varying depending on what quadrilateral we are talking about. So we have again something called a kite. So a kite has this length, this other length here equals to this length here, and then this one here also equal to that. See, yeah. So every time you see that, then you know, and then the diagonals, they are not bisectors, but they are perpendicular to each other. You know, they are not necessarily bisectors of each other, but they are perpendicular. So we say the diagonals are perpendicular bisectors of each other. No, we have this AB, diagonal AB, or let me say AB, and then this is CD. So you could say the longer diagonal could be a perpendicular bisector of the shorter, you know. In this case, you know, so this diagonal here bisects the other. Of course, BD does not bisect this. So we'll modify this. So one of the diagonals bisects the other, you know. So we have this one here bisecting the other one, but this one does not. And then the diagonals here are perpendicular to each other. So the diagonals are perpendicular to. So you erase this one here. So you say the diagonals are perpendiculars. They are perpendicular to each other. The diagonals are perpendicular to each other. That one is true. But they don't bisect. Only one of the diagonals bisect the other. Yes. So the second statement here is correct. One diagonal is a perpendicular bisector of the other. So you will see which one is a perpendicular bisector of the other. It varies depending on what type of a kite you are dealing with, or how the diagram is drawn. You know. So one diagonal is a perpendicular bisector of the other, like diagonal AC is a perpendicular bisector of BD. We have one of the diagonals again is an angle bisector of opposite interior angles. You can see diagonal AC, this angle here is equals to that. See, again, this is equal to this. And that is not the case with this other diagonal. So it's just one of them. You know, those are the characteristics that you will, you know, how do you come to a conclusion that the figure that you're seeing, the plane figure that you're seeing is a kite? You have to look at these characteristics. And then opposite interior angles are then equal. So this angle here is equals to the other one. So this angle here equal to that. And of course, this is equal to the other one as well. So opposite interior angles are equal in measure or in size. So that is how you would be able to classify the quadrilaterals and give them different names. So you don't just say this is a rectangle. No, you have to highlight certain characteristics. Certain characteristics it displays, you know, for you to be able to conclude. So when I see these characteristics that we have highlighted here, the diagonals are perpendicular to each other. One diagonal is a perpendicular bisector of the other. One of the diagonals is an angle bisector of opposite interior angles, and opposite interior angles are equal inside. Then I can confidently conclude that that is a kite, you know. So it depends on the characteristics that you are able to identify. We have another one here called the rhombus. So a rhombus behaves more or less like a parallelogram, you know. It also has two pairs. So this has two pairs of parallel sides. So not one, there are two. So two pairs of parallel sides. We have this one here, parallel, that's the first pair, and then we have this. So just like a parallelogram, it has two pairs of parallel sides. And then all sides are equal. That now makes it different from a parallelogram. All sides are equal in length. All sides are equal in length. See, and then the diagonals are perpendicular bisectors of each other. You can see that. And then the diagonals bisect the interior angles. So interior, the diagonals bisect the interior angles. Like if this is A, this is B, this is C, and this is D. Diagonal AC is a bisector, so this angle here equals to the other one there. The same applies to diagonal BD. This angle here equals to this. That wasn't the case with the parallelogram. So there are a few characteristics they share, but there are a few other characteristics that are varied, that are different depending on whether it is a parallelogram or a rhombus here. Then the diagonals divide the rhombus into four equal right-angled triangles. So this equals to this, equals to that, equal to that. And then of course we've said the diagonals are perpendicular bisectors of each other. So that will help us when possibly you wanted to find the area of this. You can basically find the area of one of the triangles and then you multiply by 4. We have a square. It has two pairs of parallel sides, just like the rhombus. Again, this side is parallel to this. This is parallel to this. Again, all sides are equal. You see, now what makes the square different from the rhombus again, here the diagonals are equal in length. See, the diagonals are equal in length. And all the interior angles are right angles. That wasn't the case with the rhombus. All sides are equal, diagonals are perpendicular bisectors of each other. Because that one they share with the rhombus, even the rhombus that was the case. We have a trapezium, exactly one pair of parallel sides. So this makes it different from a parallelogram. A parallelogram had two pairs of parallel sides. Now a trapezium has exactly one pair. So there is only this. Let's see. So we say now a trapezium with two opposite sides equal in length is called isosceles trapezium. So if you have this equals to this, then that's called isosceles. So base angles of isosceles trapezium are equal. Apart from having all the interior angles summing up to 360 degrees, you can conclude that this is equal to this, if it is an isosceles trapezium. So that is all. We have a few questions here to help you practice. We have state any two characteristics of a parallelogram. We've discussed about that. Briefly explain how a kite is different from a trapezium. Give two reasons why a rhombus is considered to be a special type of a parallelogram. Yeah, what characteristics do they share? Then a square and a rectangle share certain characteristics in common. State any two of these. So you can always attempt when possible. Otherwise, that marks the end of our lesson. Till next time, goodbye.